Hello everyone. Welcome to this guide on preparing for the Databricks Professional Data Engineer certification exam. In this session, we'll walk through the key exam domains and essential concepts you need to master to succeed. From understanding the Databricks platform architecture and security best practices to advanced topics like data modeling, pipeline design, and performance optimization, we'll cover things step by step. Along the way, you'll gain insights into real-world scenarios, troubleshooting techniques, and best practices for monitoring, testing, and CI/CD. So let's start by exploring the certification overview and exam structure, setting the foundations for your study plan. So in this exam, you're probably going to see around 60 to 65 scenario-based questions, and you'll have around 120 minutes. You need at least a 70% to pass the exam. The exam covers 5 key domains: platform and tooling, pipeline design and development, modeling data, performance and optimization, and monitoring and testing, weighted accordingly. Focus areas include hands-on skills like schema evolution, partitioning, cluster configuration, and troubleshooting. Next, let's dive into some of the platform and architecture capabilities. For this exam, you'll need to understand key details around workspace components like notebooks, jobs, clusters, and Unity Catalog. It's important to know the difference between job clusters and all-purpose clusters, and key features such as auto-scaling, spot instance fallback, and auto-termination. For job orchestration, be familiar with REST APIs, Databricks Connect, and the CLI for automation and CI/CD workflows. Managing Databricks from an IDE like VS Code is also a valuable skill to know for this exam, allowing you to develop and debug code efficiently. When it comes to security, know how to manage secrets securely using scopes and cloud key management integrations. Remember that the sh command lets you run shell commands on the driver node only, and co-locating compute and storage improves performance by reducing latency and cost. In the CI/CD space, Databricks asset bundles play a crucial role by packaging notebooks, jobs, and configuration files for automated and reliable deployments. Tools like GitHub Actions and Azure DevOps integrate with Databricks CLI and DABs to orchestrate seamless CI/CD pipelines. Testing and version control are equally essential. Write unit and integration tests using PyTest and DBX frameworks, and leverage Databricks repos to manage your code versions and enable effective collaboration across teams. Data security and governance components will also be tested. Remember that job ownership is user-specific, groups are not supported, and admins can assign ownership when needed. Job run histories are retained for 60 days with export options for transparency. Always follow best practices to securely manage secrets and credentials. In terms of secret management, use secret scopes for secure credential storage. For example, you can use widgets like dbutils widgets.txt and retrieve values with dbutils widgets.getDate. Be aware of limitations. For example, iterating over a secret value and printing it character by character exposes the secret in plain text, bypassing Databricks secrets usual redaction, so avoid this practice. Unity Catalog provides fine-grained access control with a 3-level namespace: catalog, schema, and table, including granular permissions down to the column level. You'll want to know how to apply data masking, row-level security, and auditing to meet compliance requirements. In this section, focus on ingestion and streaming. Autoloader is great for incremental file ingestion with schema inference and evolution, plus checkpointing for reliability. Lakehouse declarative pipelines, formerly Delta Live tables, offer declarative pipeline building with quality checks and fault tolerance. Structured streaming supports advanced features like event time processing, watermark, deduplication, and windowed aggregations. Remember, stream static joins for efficient queries, and that checkpointing is what keeps your streaming pipelines fault tolerant. Since this is a professional exam, you'll be expected to know the granularities of these capabilities from setting them up to optimizing them, be able to select the appropriate ingestion pattern based on specific use case requirements. Data modeling on Databricks requires understanding both Delta Lake capabilities and table management features. Delta Lake offers key features that ensure reliable data management on the lakehouse. It provides ACID transactions for consistent and fault-tolerant data operations. Schema evolution allows your data structure to adapt over time without disrupting workflows. Plus, time travel enables querying and restoring previous data versions for auditing and recovery, making your pipelines robust and flexible. Delta Lake time travel allows you to query historical data versions by timestamp or version number, handy for debugging and audits. Default data retention is roughly 7 days to balance storage overhead. It's not meant for long-term archival, so regular vacuum operations are recommended. Time travel operates on versioned Parquet files and transaction logs, providing strong transactional consistency across your tables. From a table management perspective, know the intricacies of managed versus external tables. Managed tables control the entire data lifecycle, including storage. External tables, on the other hand, manage only the metadata, while the actual data resides outside the Databricks system. When creating an external table, specify the keyword location to point the data storage path. In Databricks, also remember that foreign key constraints aren't enforced, so integrity is managed by your applications or ETL processes. Regarding clones, deep clones create a full physical copy of the data table. This means if the source data is deleted or changed later, the deep clone remains unchanged because it's fully independent. Conversely, shallow clones only reference the source data files without duplicating them. So if the source data is deleted, the shallow clone will lose access to that data. Also, updates to the shallow clone reflect in the source data and vice versa, since they share the same underlying files. You should also know the medallion architecture, which structures data into bronze raw, silver cleaned, and gold business-ready layers, supporting controlled, staged transformation to maintain data quality and governance. Finally, use views for lightweight virtual tables to simplify query reuse without storage cost. Materialized views when query performance needs to be optimized by storing pre-computed results, and tables when you require persistent, managed storage with full transactional support. Optimizing performance is key, and it's definitely going to be something that you'll be tested on for this exam. Auto-optimize aims for a 1 GB file size during writes, and auto-compaction merges smaller files to around 128 MB to improve query speed and storage efficiency. Delta Lake collects statistics on the first 32 columns to enable data skipping during queries, improving speed, though it's less effective with free text columns. Predictive optimization extends stats on managed tables. Z-ordering complements data skipping by clustering related data within the files based on chosen columns, significantly boosting query performance on selective filters. Use optimize and vacuum regularly to keep your data layout healthy, and consider caching, broadcast joins, and adaptive query execution for further enhancements. To optimize performance, avoid using the display function on large data sets or in production code because it triggers immediate execution and data retrieval to the driver, which can cause high memory usage, longer execution times, and slow down your jobs. In monitoring and troubleshooting Databricks workloads, the Spark UI is your primary tool for digging into job and stage metrics, helping detect common issues like data skew and task failure. For streaming jobs, the Streaming Query UI provides real-time insights into latency and watermark progress, while DLT dashboards let you monitor Delta Live table pipeline health. It's also essential to review cluster event logs to understand cluster lifecycle events and failures, and use the Ganglia UI for monitoring cluster resource utilization, such as CPU and memory in real time. For production stability, job run history is kept for 60 days and can be exported to HTML for auditing. Setting up alerts on job failures, SLA breaches, and resource bottlenecks is critical, often automated through Databricks REST APIs and CLI integrations. When troubleshooting, always run notebooks at production scale run all to ensure workflows behave as expected end to end. Deep dive into logs, checkpoint information, and error messages to identify root causes. Parameterizing your notebooks helps isolate problems and reproduce issues reliably for efficient debugging. To wrap up, the key to success in the Databricks Professional Data Engineer exam lies in combining strong conceptual understanding with practical, hands-on experience. This exam is scenario-driven, so focus on doing labs and practice projects to solidify your application of core concepts like platform architecture, security, data modeling, pipeline design, and performance tuning. Make sure to leverage official Databricks learning resources and documentation. They're your best guides for exam content. Don't overlook the value of engaging with the community through forums and discussion groups where you can clarify doubts and learn from peers. Automation and CI/CD topics frequently appear in scenarios, so gain familiarity with Databricks REST APIs, CLI, and related tooling. During the exam, manage your time wisely, read each question carefully, and apply your practical knowledge to solve real-world problems. Confidence comes from preparation, so trust your experience. Best of luck. You're well on your way to becoming a certified Databricks Professional Data Engineer.